Studies Section 9. Special Probability Distributions. Introduction. In the last lecture, we introduced the concept of probability and random variables. In this lecture, we shall examine some major probability distributions that are widely used in social sciences. This lecture concentrates on discussing the binomial and the normal probability distributions. Objectives. After this lecture, you should be able to 1. Use the binomial and normal distribution in a more detailed manner. 2. Understand the characteristics of and why some social phenomena are classified under binomial and others as normal distribution. Pretest. To be taken before you read this lecture: 1. The binomial probability distribution can be said to be A one-chance experiment, B. A normal chance experiment, C. A good chance experiment, D. A two-chance experiment. 2. In a binomial distribution, the probability of success P is equal to 0.4. What is the probability of failure Q? A. Q is equal to 0.4, B. 0.6, C. 0.8, D. 1.0. 3. If the standard deviation of a binomial probability is square root of NPQ, what is the variance of the distribution? A. NPQ, B. N squared, P squared, Q squared, C. NPQ squared, D. Square root of NPQ. 4. What is the shape of a normal distribution curve? A. Circular, B. Longitudinal, C. Bell shape, D. Oval shape. 5. The standard normal variance Z has a mean 0 and standard deviation of A. 1, B. 2, C. 3, D. 0. Content. Section 1. The binomial distribution. The two-chance experiment, like voting or not voting, opinion polls for or against a state policy, winning or losing an election, and many more are examples of social science phenomena that follows a binomial probability distribution. Binomial probability distribution has the following characteristics. 1. The experiment involves a series of repeated trials. 2. The possible outcome for each trial can be expressed in terms of a dichotomy, success or failure, head or tail, male or female, etc. 3. The random variable involved is the number of success in n trials. 4. The probability of success on each trial is constant from trial to trial. 5. The repeated trials are independent. Let us illustrate these characteristics with an example. In an election where there are 500 registered voters: 1. The voting experiment involves a series of repeated trials because there are 500 registered voters. Thus, the experiment could go on 500 times. The first characteristic is satisfied. 2. The second characteristic is also satisfied because the outcome for each trial can be expressed in terms of a dichotomy, vote for or vote against a particular candidate. 3. If our success is the event vote for, then the random variable involved is the number of success in 500 trials. Thus, the third characteristic is satisfied. 4. This characteristic is also satisfied because the probability of success from one voter to the other is constant. That is, if we assume that the probability of voting for P is equal to 1 over 2 and the probability of voting against Q is equal to 1 over 2, then P and Q are constant from trial to trial. 5. The repeated trials are independent because all the voters can vote at the same time. The question now is, how do we compute this probability? This leads us to the next unit. The binomial probability function. If P is the probability that an event will occur in any single trial, called the probability of success, and Q is equal to 1 minus P is the probability that it will fail to occur in any single trial, called the probability of failure, then the probability that the event will occur exactly x times in trials, that is, x successes and n x failures, is given by probability of x is equal to x in bracket is equal to n combination x, p raised to power x, q raised to power n minus x, equation 9.1, where x is equal to 0, 1, 2 to n, and n combination x is equal to n factorial over x factorial n minus x factorial in brackets. Note that n combination x reads n combination x. N factorial reads n factorial. N factorial is equal to n into bracket n minus 1 bracket closed n minus 2 into brackets. That's 1. 3 factorial is equal to 3 times 2 times 1 is equal to 6. 5 factorial is equal to 5 times 4 times 3 times 2 times 1 is equal to 120. 0 factorial is equal to 1. Equation 9.1 is called the binomial probability function. Example 9.1. Suppose it is known from past experience that approximately 90% of human beings contacting HIV virus die within 10 years of infection. Given that 5 people in a certain town contact the disease, use the binomial probability to find the probability that exactly 4 of them will die within 10 years. Solution. In this case, dying of the virus is the success P. Surviving beyond 10 years is failure. Q is equal to 1 minus P. From the question, P is equal to 90% is equal to 90 over 100 is equal to 0.9. Therefore, Q is equal to 1 minus P is equal to 1 minus 0.9 is equal to 0.1. N is equal to 5. 5 people involved. X is equal to 4. Exactly 4 died of the virus. Using equation 9.1, P bracket open x is equal to x bracket closed is equal to n combination x, p raised to power x, q raised to power n minus x. P x is equal to 4 in bracket is equal to 5 combination 4, 0.9 bracket raised to power 4, 0.1 bracket raised to power 5 minus 4 is equal to 5 factorial over 4 factorial, 5 minus 4 in bracket factorial, 0.9 in bracket raised to power 4, 0.1 in bracket raised to power 1 is equal to 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1 times 1. 0.6561 in bracket 0.1 in bracket is equal to 5 into bracket open 0.6561 bracket closed bracket open 0.1 bracket closed is equal to 0.32805 is equal to 0.33. Now, you should try and solve the above problem on your own, but use the figures supplied below. Use P is equal to 80%, N is equal to 4, X is equal to 3. Just follow the same procedure as in the solved example. Mean, variance, and standard deviation of a binomial distribution. As we have discussed in Lecture 4, the mean, variance, and standard deviation are useful parameters in describing social information. The binomial distribution has its own standard computation formula for all these parameters. Computation formulas for the parameters in binomial distribution are as stated below without proof. Mean x bar is equal to NP. Variance standard deviation square is equal to NPQ. Standard deviation is equal to square root of NPQ, where N is the sample size, P is the probability of success in any trials, Q is the probability of failure. Mean is sometimes referred to as the expected number. Also note that the mean, variance, and standard deviation discussed in this section have the same meaning with the ones discussed in Lecture 4, but different computation formula. Section 2. The normal distribution. The most useful and most famous continuous probability distribution is the normal probability distribution. Most observable or measurable phenomenon in the social sciences can be said to be approximately normally distributed. The usefulness of the normal curve is due to the frequency of occurrence of near normal relative frequency distributions of social science data. Lehman Oath, 1983, page 162. Properties of the normal distribution. 1. The curve of a normal distribution is bell-shaped. 2. The mean, median, and mode of the normal distribution coincide because the distribution is symmetrical and single-peaked. Most of the observations are clustered around the mean with few items in the extremes. 3. Its features are fully characterized by the value of the mean and standard deviation. 4. Area under the curve can be determined approximately as follows. A. 68.27% of this area is between mean plus or minus standard deviation, that is, one standard deviation from the mean. B. 95.45% of these areas falls within mean plus or minus 2 standard deviation, that is, 2 standard deviation from the mean. C. 99.73% of this area falls within mean plus or minus 3 standard deviation, that is, 3 standard deviation from the mean. 5. Instead of using the raw value of normal variate x, it is more convenient to use its standardized form. The standardized form is given as z is equal to x minus mu over standard deviation, equation 9.2. This means that x has mean and standard deviation, but the variate z has mean 0 and standard deviation 1. Z is the standard normal, variate, or score. 6. For a standard normal curve, the corresponding value in respect of 4 above are 1, minus 1, and plus 1, 2, minus 2, and plus 2, 3, minus 3, and plus 6. The standard normal curve for different values of z is tabulated for the use of researchers. This is called the table of normal distribution function. See the appendix. Let us illustrate the discussion in this section with an example. Example 9.2. Suppose that the per capita income of all countries in Africa is normally distributed with mean $230 and standard deviation $20. Use the normal distribution to find the probability that a particular country selected in Africa has a per capita income that is 1. Greater than $280, 2. Less than $220, 3. Between $220 and $280. Solution 1. Using equation 9.2, where mean is equal to 230, standard deviation is equal to 20, x is equal to 280. Step 1. Compute the z-score. Z is equal to x minus mean over standard deviation. Probability of x greater than 280 in bracket is equal to 280 minus 230 over 20 is equal to 50 over 20 is equal to 2.5. Step 2. Shade the portion on the normal curve. The portion can be shown on the normal curve as below. X is greater than 280 shaded. Step 3. Read the value on the normal table. The area A corresponding to Z is equal to 2.5 on the normal table is 0.4938. But on figure 9.2a, the entire area to the right of the mean 230 is 0.5. Thus, the area of the shaded portion is 0.5 minus 0.4938 is equal to 0.0062. Therefore, the probability that the country selected has a per capita income greater than $280 is 0.0062. This is a very weak probability. Probability most countries will fall below the mean value. 2. The required probability is P x is less than 220 in bracket. First step, compute the z-score. Z is equal to x minus mean over standard deviation is equal to 220 minus 230 over 20 is equal to minus 10 over 20 is equal to minus 0.5. Second step, shade the portion on the normal curve. X less than 220 shaded. Third step, check the area up in the standard normal table appendix. The negative value of Z indicates that the point 220 is to the left of the mean, figure 9.2b. Thus, the area A corresponding to Z is equal to 0.5. Neglecting the negative sign is 0.1915, but the entire area to the left of 230 is 0.5. Therefore, the area of the shaded portion is 0.5 to 0.1915 is equal to 0.3085. Therefore, the probability that the selected state has a per capita income greater than $220 million is 0.3085. This is quite higher than the probability in one above. 3. We are required to compute probability of bracket open 220 less than x less than 280 bracket closed. Step 1. Compute the z-score for both sides. Left, Z is equal to 220 minus 230 over 20 is equal to minus 10 over 20 is equal to minus 0.5. Right, Z is equal to 280 minus 230 over 20 is equal to 50 over 20 is equal to 2.5. Step 2. Shade the portion on a normal curve. Bracket open, 220 less than x less than 280 shaded, bracket closed. Step 3. Read off the area on the standard normal table. The corresponding area A1 is equal to 0.1915. A2 is equal to 0.4938. The required area is equal to A1 plus A2 is equal to 0.1915 plus 0.4938 is equal to 0.6853. Which is the required probability that the selected state has a per capita income between $220 and $280? Summary. The most widely used probability distributions in the social sciences are the binomial and the normal distributions. The binomial distribution is a two-chance experiment that involves a series of repeated trials. The normal curve is bell-shaped and its features are fully characterized by the value of the mean and standard deviation. The normal variate has been standardized as the z-variate whose values are tabulated. This is the end of study section 9. Thanks for listening.